All right, we're in section 1.5, example 1, and we see that we're trying to solve inequalities. Now, you'll notice that solving inequalities is pretty much identical to solving an equation, at least the algebraic portions of it. There's one thing that we'll see that's different when we're in part B. But just imagine if there was an equal sign where we see this less than. And see how you would do it almost identically. How we express our solution in the end is most definitely different, but let's go ahead and go through the algebra. All right, so first we would deal with this plus 1, as you would imagine, and we would subtract 1 from both sides of the equation. That would cancel the positive 1 from the left side of the equation. We'd be left with 2x is less than, so the inequality stays the same, less than 6. Okay, and then as you would imagine, we would then divide by 2 on both sides of the equation, and we would get x is less than, still less than, 3. So you just keep the same inequality so far. As you can see, doing all these operations, we keep the same inequality. Now we need to express our solution, and realize what we've determined is any value that is less than 3, that's what this is saying, any value that is less than 3 will satisfy this inequality. So think about that. So like if we were to choose by chance like 0, 0 is less than 3, so then it will satisfy this equation. So 2 times 0 is 0, plus 1 is 1. 1 is less than 7. No, you'll notice that if you want to check your solution, you'll notice that any value you plug in that is less than 3 will satisfy your original inequality. Now, we want to express our solution possibly in 3 different forms. There's set builder notation, interval notation, and graphically. Now, typically with an equation, if we had like x equals 3, which would be the solution to 2x plus 1 equals 7, you would be done. There's nothing else to do. But inequalities, there's 3 different ways we may want to express our solution. Set builder notation, which is, so I'll write this down, set builder notation. You would have x, you always have the form like the open bracket, x, vertical line, and then something in the middle, and then you close your bracket. And then essentially all you need to do is just take this x is less than 3 and place that right there. Okay, we're done with set builder notation. What this is saying, and what's really nice about this, is that this will translate into English, from math into English. So this is saying the set of all x values, all real solutions, and then such that, the vertical line means such that, x is less than 3. All real solutions that meet this criteria will be our solution. You don't really need to know how to interpret it, but I'm just sharing that with you. Now, if we want to put this in interval notation, I actually think graphically is a little bit easier to do first. So graphically, you just want to draw a number line. So this is the graphical way of explaining this. So you start out with maybe 0, go up 1, 2, 3. So we're up at 3. And this does not include 3, doesn't include 3. And it's going less than. So it's everything less than 3, as I discussed before. It's anything below 3. And we're going to just shade that all in and draw an arrow. And there we go. So this is going towards negative infinity. It's going down forever. And that's how you express it graphically. And looking at it graphically can help you draw your interval notation. So there's also interval notation. Interval notation You can look at this and see that this is going from negative infinity, is over in the left forever. We write it from left to right, from smallest to largest. Negative infinity up to the highest value of 3, not including 3. And there we go. And you never include infinity or negative infinity. So you always have that type of bracket, soft bracket. And because you can never reach that ending point of negative infinity. And those are the 3 different ways you may want to express your solution. Okay, so quickly we'll go over the next problem. Okay, so treat this the same, and we just want to solve. Notice that this includes equal. It's less than or equal to 10. Okay, so we will include our solution at the end. So anyways, we'll get to that in a little bit. So as you would maybe imagine, you would add 2 to both sides. And then we're left with negative 3x is less than or equal to 12. And then we divide by negative 3. Now here's the thing to keep in mind. When you multiply or divide by a negative number, you have to switch the inequality. So this becomes greater than or equal to. It goes from less than or equal to greater than or equal to. This becomes negative 4 and x. So x is greater than or equal to negative 4. That's our solution. And quickly, to do set builder notation, as I mentioned before, you kind of just copy and paste it right in there. So I'm just going to put set builder notation right here. There's set builder notation. We're done. As you can see, you just put the same bracket x, vertical line, then bracket at the end. Now, graphically, we would have negative 4, and it would be greater than or equal to. The way to write this out is, okay, so we'd have 0, 0, negative 1, negative 2, negative 3, negative 4. And it's greater than or equal to. So it's everything above negative 4. So we would want to use a hard bracket like this, pointing in the right direction, because we want to include negative 4. So soft bracket is just a rounded bracket, and then like a square bracket to include the value. And then it goes to the right, because everything to the right of negative 4 will satisfy x is greater than negative 4. For example, if we plug in 0, 0 is greater than or equal to negative 4. So there's the graphical display of the solution. And then we can determine how to write out interval notation, the same direction of the bracket, going from smallest to largest. It goes up to infinity, and you never include the infinity. So that's how you write set builder notation, graphical notation, and then interval notation. All right, let me know if you have any concerns, and I'll be more than happy to help.